let's take a couple minutes and look at some symmetry here. Symmetry is an important part of our world. Lots of things are symmetrical, like this butterfly here. If we look, we have a kind of left and right halves are the same. That is what we call symmetrical, right? So we want to be able to find some symmetry here, okay? So here's an object that has some symmetry. This has got some reflection symmetry. So reflection symmetry means we have two halves, in this case left and right, that are exactly the same. So we could draw a line through the middle here, and you can see that these two halves are symmetrical. So that kind of pinkish shape there is symmetrical. Okay, that's called a line of reflection or reflectional symmetry. This one doesn't have a line of reflection. We can't draw a line right through the middle. If you fold this over, the right side's not a reflection of this side. But what we can do is we can rotate this. So let's see. Let me kind of change the way it looks a little bit there. All right, so there we got these 4 points. Maybe it'll go like that. There we go. So we got these 4 points. Now notice if I'm going to spin the whole web page here. And look at that. Now that looks the same as it did before. There's 1 spin. There's 2 spins. I could spin it another time. And I'm doing these kind of quarter turns until we get right back where we started. So a full 360 degrees is a quarter turn, but here we can do it. I'm sorry, let me back up. Full 360 degrees is a full turn, but we can cut that into quarters, and we can actually rotate it 90 degrees. So 90 degrees is 1 quarter turn. That will make it map onto itself. So we call this mapping onto itself, where it looks exactly the same. So we take this shape and we spin it, and it looks exactly the same way it does. Got to be careful, I'm stretching it too, but right? So that's a quarter turn. A quarter turn would be a 90-degree turn. So it only takes a quarter turn to make it look the same. Or we could do 2 quarter turns. That's 180 degrees. Okay? So if we go 2 quarter turns, we get 1, 2. Then it looks the same. Okay? So that's a 180-degree rotation there. If we take this 3 quarter turns, well, 3 times 90 is 270 degrees. So 270 degrees will also make the shape look like itself. All right? So there's that's called rotational symmetry. We measure rotations in degrees, all right? So here we got a shape. We want to say, are there any lines of symmetry? Well, yeah, we do have some. We've got, let's see here. Let's go back. So there's a line right there. If we were to fold it in half, we'd have this left half and the right half would be the same. Okay. If we were to draw a line right down the middle here and fold it in half this way, then this side would map right onto that. We'd flip it over, and map means it would land right onto it. So there's 2 lines. You might wonder about maybe this line. Well, that one doesn't quite work because this would end up over here. It would not fold over on itself. Okay, so we got to take that one off. Are there any angles of rotation? Well, if we rotate this, and I'm going to go like this, if I rotate it like that, 180 degrees, it looks the same. But if I rotate it from where it started, I only go a quarter turn, that's a different shape. So our only degrees of rotation here is 180. We could also do a 360 there, but we're not going to worry about 360. We just care about the degrees that are less than 100 or less than 360. So great. Well, let's look at a couple more here. How about this one? Well, this has a line of reflection. You see it? So if we split it vertically right down the middle there, well, I kind of missed there, huh? So if we split it right down the middle here, we can fold it over left and right. Okay, let's pretend that's the middle. So it has one line of reflection, that's it. Horizontal won't work, diagonal won't work. And can we spin it at all? Well, if I spin it 90, that doesn't work. 180? Nah, because the short side's up, doesn't look the same. 270? No. Okay, so 360 puts us back where we started. So no, there's no rotational symmetry here. So that's the idea there. All right, so we have one line of reflection and no lines of symmetry. Let's look at one more. How about this one? Well, we could cut it right through the middle there, fold top and bottom, and this side would fold down to here. So there's a line of symmetry. How about, what if we do it vertically? There's another line of reflection, assuming that I actually hit that. Okay, so if we fold it right on this green line, this side would fold over to there. Okay, so that's a line of reflection. What about diagonally here? Well, if we went right through there, then this half would fold over onto here. Can you see if we fold on that red line, we'd have a perfect match. Or you can think of it as if we flip it. Okay. In the same way, we could go right through here. Okay, so those are all good lines of reflection. There's actually 4 of them. And what about rotation? Well, we can rotate this. It looks like it's probably going to be the same here. So if I rotate it, that's 90 degrees. Still looks like an X. 90 degrees, or 180 total. Okay, so we get the same looking shape as we go there. All right, so that's the idea. All right, so we got rotations of every multiple of 90 degrees again. So 90, 180, so on and so forth. So that's the idea, okay? And the way to get these angles, by the way, is think of how many times it could turn to get around to 360, all right? Or you can see, in this case, there's 4 of these angles that look the same, 4 of these edges that look the same. And so that kind of gives us a clue that it'd be 4 rotations. 360 divided by 4 is 90, and then every multiple of 90. And we could put 360 in there, but we usually don't. So, all right, that's the idea for reflectional and rotational symmetry. Hope that helps. Have a great day.